Hello students. So today we'll begin where we left in the previous video, and that was at mathematical operations, and we'll now begin with exponents. Exponents, also called powers, is basically repeated multiplication. As we have seen, multiplication is repeated addition. Similarly, this exponents or powers are repeated multiplication. So I think you might well be aware that 2 multiplied by 4 times 2 into 2 into 2 into 2 can be written as 2 to the power 4. This is called 2 to the power 4. Okay? This is what exponent is. This is 9 into 9 into 9. So 9 to the power 3. Power 2 and power 3 have also specific names. We call squares and cubes. Squares meaning multiple, same number multiplied 2 times. So 4 into 4 is 4 square or 4 to the power 2. And 4 into 4 into 4 would be 4 to the power 3 or 4 cube, square and cube. And as I said yesterday, you should remember square still 30 and cube still 15. That would serve you well. Based on only this knowledge, we can solve this question of CSE 2020. It's very easy. Question dekho. For what value of n, sum of digits of this number is 2. And we have option in front of us. For n equal to 0, you can put n is equal to 0 here. 10 to the power 0 plus 1 would be 10. Any number to the power 0 is by definition 1. So this would be 1 plus 1, which is 2. So sum of the digits is 2. Yes, so 0 ke liye to true hai. For any whole numbers are 0, 1, 2, up to infinity. 0 ke liye, that is of course true, that we have seen. And for any other number, 10 to the power 1, 2, 3, 4, kuch bhi ho, 10 to the power n, this would be, this number 10 to the power something would look like 1 followed by that many zeros. 10 to the power 2 is 100, 10 to the power 3, 4, 5, 6, dot, 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 dot. And plus 1 would just give 1 at the units place. So this number is what this will look like. And sum of the digits, 1 plus 1 again 2. So that's for any whole number n is also true. N is equal to 0 is also true. We have to choose again most general option among these 4. For any positive integer n only, positive integers meaning 1, 2, 3, 4, others are negative integers. 0 is neither positive nor negative. So positive integer, this is also true, but B option, whole number already includes positive integer. And here it is only meaning not, this is not true for any other numbers, but that is not the case because it is true for 0 as well. So option C becomes incorrect. And for any real number n, real number C include rational and irrational numbers. That is a vast array of numbers, and this won't be true because you don't know something like 10 to the power root 2. You don't know what that means. Or 10 to the power what 1.11. You don't know what that means. So it is not true for any real number. So correct option here is B. It is true for any whole number n. Fine. Square, square root, cube, cube root, that I have already talked about. Squares and cubes. And if square, which is 2 square, is 2 into 2 is equal to 4, then we say that square of 2 is 4 and square root of 4 would be 2. But you should also observe that minus 2 square, which is by definition minus 2 into minus 2, which is equal to 2 into 2, 4, and minus minus plus. So it is also 4. So square of minus 2 is also 4. So if we take square root of 4, it is actually plus or minus 2. There are 2 square roots of 4, not only 1. And this becomes important in a question that we have seen yesterday, where sum of 3 consecutive integers is equal to their product. We use this fact that square root of 4 can be plus or minus 2. It is not only plus 2, minus 2 is also square root, because minus 2 square is also 4, like 2 ka square. And similarly cube, 2 cube is 2 into 2 into 2, which is 8. Then cube root of 8 is 2. Here there is no plus minus because minus 2 into minus 2 into minus 2 would be minus minus plus, plus minus minus. So it would be minus 8, not plus 8. So cube root of 8 is 2, not minus 2. But square root of 4 is plus or minus 2 both. Fine. See, square root has 2 possible values. Square root of 4, for instance, can be 2 as well as minus 2. Square root of 9 is plus 2 or plus 3 or minus 3, and so on. So here minus possibility is also to be taken into account, especially if the question talks about integers. Next, this is a very intriguing note that square of any integer is always positive, because integer can be positive, negative or 0. 0 square is 0. Then positive number ka square would be positive, of course. Plus 2 into plus 2, that would be plus 4. So it will be positive. And square of minus numbers, negative numbers is also positive, because in multiplication we have seen minus into minus becomes plus. So minus 2 square is also 4. And minus 5 square is also 25, plus 25, not minus 25. So square of an integer is always positive, or at least non-negative, because if we include 0 ka square as 0, we cannot say 0 is positive. So, but definitely we can say non-negative. And next intriguing fact is units place for any square will always be one of these: 0, 1, 4, 5, 6 or 9. How? We'll see. If you look at how multiplication is performed, like for example, I'm taking random example, 11 ka square if I want to do, then it is 11 into 11. What we do? We do 1 into 1, which is 1, 1 into 1, which is 1. Then we add 1, 0, then 1 into 1, 1, 1 into 1, 1. So we do this. So this 1 into 1, 1 is the units place here. And here, when we multiply by tens place from this side, we are putting here 0 and then starting multiplication from here. Starting to write multiplication from here. So if you look at standard multiplication, only the digits at unit place will matter or will determine the units place of the multiplication. I'll take any other example. 1, 2, 3 into, let us say 2, 3, 2, 4. Okay. How will we do? 4 into 3, which is 12. Carry forward 1. 4 into 2, 8 plus 1, 9. 4 ones are 4. Yes. And then we'll put 0 here, and 2 into 3, 6, 2 into 2, 4, 2 into 1, 2. So this will be the addition, whatever. So look at this units place of the product of these two. Is it not the same as 4 into 3, 12 cut units place? Because of this style of multiplication, when we start multiplying, we multiply here and that comes at the unit place here. And below that number, all the things which we add have 0 at units place. So when we add units places, only this thing will determine the units place. That is why when we multiply any two number, however large, only the multiplication of units places will determine the units place of the product. You can take any example: 1, 2, 4, 1, 2, 4, 5 into 2, 3, 4, 3. And I just want to find out units place of this. I'm not interested in other digits. So it will be just 5 into 3, 15. 5 would be the units place. Any other examples we can take? 5, 9, 6, 7 into 1, 0, 0, 3. What would be the units place? 7 3s are 21. 1 would be the units place. Other digits will differ, but if I just talk about units place, that would be just units place of this product of unit digits, units place digits. Keeping this in mind, let us find out the squares. So if we have any number ending with 0 ka square, this will be like this number multiplied by itself. So what is the units place? 0 into 0, which is 0. Something at the end 1 hai, then square is 1 into 1, 1. Something at the end, if you have 2 into 2, 4. Something at the end 3 into 3, 9. Something 4 into 4, 16 ka 6. I'm just writing out units places. Huh? Something 5 ka square, 5 square is 25, so 5. 6 square is at the end 6 square, 36 ka 6. Something at the end 7 square, 7 sevens are 49, end mein unit place is 9. If we have number ending in 8, 8 square, 64 ka 4. Then something ending with 9 square, 81, so 1. And again become 0, 0 we have already taken. So these are all the possibilities. Any number in the world you can have, any integer, its square, if we take into account, then units place of those square numbers will always be one among them. So 0 can be there at the end, 1 can be there, 2 cannot be there, 3 no, 4 yes, 5 yes, 6 yes, 7 yes, no 7 no, 8 no, 9 yes, and 0 yes. So these are the possibilities. So basically what I'm trying to say is, if we have been given any square number, So units place of that square will always be 1 among them. 2, 3, 7 or 8 cannot be at the units place of any square number. So if you are given a number and you are asked which among the following is not a square, if you have any one of them at the units place, that is definitely not a square. That much you can say just by observation. Fine. Then again, let us look at some PYQ. We have, see, age of Mr. X last year was a square number and it would be a cube next year. So if you look at today, last year it was a square number, next year it was a cube number. So we are looking for two numbers, one is a square, one is a cube, and difference among them is 2, because this is last year, next year, so difference between these 2 years is 2. So we are looking for one square and one cube such that difference between them is 2. Just writing first few squares and cubes or remembering them, you will realize that 25 and 27 are the two numbers such that this is a square and this is a cube. Last year it was a square number, next year it will be a cube. So today his age is 26. Question is, by at least which number he must wait so that his age becomes the cube number again. What is the next cube after 27? This is 3 cube is 27, 4 cube is 64. So he has to be 64 now. So how many more years? He is 26. To become 64, he needs to wait 38 years more. That's all. Very easy question. You just have to observe that we want to look for a number. We want to look for a square and a cube such that difference between them is 2. So 25 and 27 must be those numbers. You can just look for cubes like 1 ka cube, 2 ka cube, 3 ka cube, 4 ka cube. Just subtract 2 and see which of them is square. Here negative number cannot be square. Here 6 not square. 25 it is a square. So that is your answer. This is the ages that they are talking about. So today's age, present age is 26, and he has to wait for 38 more years for his age to become 64, which is the next cube number. Next, there are some important properties of exponents that you should know, and we have done this part in schools. Please take a screenshot and please remember these properties because these are important. Practice them so that it becomes easy, and all of them follow just by the definition of powers or exponents. So firstly, a to the power m into a to the power m. What do a to the power m meaning? A multiplied m times, and a to the power n meaning a into n times. And if you multiply these two, meaning how many times a is there? M times here, n times here. So total we have m plus n times of a. That is this property. Division, they will just get subtracted. A to the power 0 is 1 by definition for all numbers a, right? A to the power 0 is 1 by definition. A to the power 1 is itself number itself. A to the power minus 1 is again a to the power minus 1 is 1 by a, inverse of a. Or in general, a to the power minus n is 1 upon a to the power n. That is again there. Then this is again important property, that a to the power m to the power n is equal to a to the power m into n. Fine. This is basically a to the power m into a to the power m n times. So how many times a appears here? M plus m plus m n times, which is m into n times. Repeated addition is multiplication. We are repeatedly adding m here, which is basically m into n. But carefully see that a to the power m to the power n is not equal to a to the power m bracket power n, because this quantity is this, but this quantity is not same as this. To see this, we can just take a simple example, that 2 to the power 3 and 2 to the power 2 to the power 3. Here this quantity is equal to 2 to the power 2 into 3, 6. But this quantity is 2 to the power 2 to the power 3, which is 8. And these two are not same quantities, these two are different quantities. So please be careful that these two are not the same quantities. These two are very, very different quantities. That bracket makes all the difference. Fine. Next, AB bracket power n is equal to a to the power n into b to the power n. So this n distributes inside. Same thing is for true for division. And a to the power 1 by n, this is again, it basically means nth root of a. Like we square, cube and etc. we can take roots as well. So third root of 8 or cube root of 8 was 3. Fourth root of 16 would be again 2. Fifth root of 32 would be again 2 and so on. So this is nth root of a. And combining all the properties, a to the power m by n in general, if we take m by n as a fraction, m by n, it basically means a की power m का nth root. These are all basic definitions or properties in as far as exponents are concerned. Please, on your hand, if you feel difficulty or if you have trouble remembering these rules, please take 5-10 examples on your own and just simplify the expressions to get the ensure that you remember all the rules and you are fluent with them. Fine. They would be used in exponent ka questions. And again, if you want further explanations, you can refer to the full booklets that are uploaded on my Telegram channel, CSE IFoS with Abhishek, or you can, if you want full lectures, because here I'm not explaining everything and I'm not making you solve things because we have time crunch, we are doing a crash course. So in that case, you may want to go on LevelUp IAS website and enroll into our full course, which has been provided in recorded format, that you can do. Fine. Next, very important section from which questions every year are getting asked is the units digit in the exponents. And it follows directly, it follows absolutely directly from our definition of multiplication that I have just discussed, that how units place of the powers or unit place of the multiplication works. We are only following that. Now, this is the thing. Regardless of powers or bases involved, all we have to look for is the powers of the units places of the base. It follows directly from the definition of powers. So, if I have something like 125 ka power 4, I don't know what that number is. That number must be huge. But question is, what is the units place of this power? If that is the question, we have to know that this power 4 is nothing but 125 into 125 into 125 into 125, right? This is the thing by definition. And I have already told you that when we multiply two numbers, units place of the product only depends on the multiplication of units places of the numbers involved. I'll translate in Hindi. मतलब दो नंबर को हम जब मल्टीप्लाई करते हैं तो जो आंसर आएगा, तो उसका जो यूनिट्स प्लेस है आंसर का, वो किस पे डिपेंड करता है? वो बस ऊपर वाले दो नंबर के मल्टीप्लिकेशन पे डिपेंड करता है, यूनिट्स प्लेसेस की मल्टीप्लिकेशन पे, नॉट ऑन एनी अदर डिजिट्स. जो मैंने पहले भी बताया था, इफ आई डू दिस 125 into 125, मैं क्या करूंगा? व्हाट विल आई डू? I will multiply 5 into 5, 25, and then I'll do rest of the things. I'm just interested in units places, so I'm not writing other things. Then I want to multiply 2. अब मुझे 2 से multiply करना है 125 को, तो मैं पहले 0 ऐड करूंगा यहाँ पे, and then I'll multiply by 2. That is what I'll get. And then मैं क्या करूंगा? अब 1 से multiply करना है, then I'll have to add 2 zeros. Remember your school level multiplication कैसे करना है? Then 2 zeros add करके I'll write 125 here, and then I'll add these three numbers to get multiplication. तो यूनिट्स प्लेस अगर आप देखोगे, यहाँ पे 0, यहाँ पे 0, तो बस इस पे डिपेंड करेगा ना यूनिट्स प्लेस, 5 plus 0 plus 0. The units place of the product only depends on this multiplication, 5 into 5. Other numbers are not contributing anything to multiplication, to rather units place of the multiplication. तो इसलिए ये 5 into 5, ये 25 का 5 ही आएगा नीचे. वैसे ही, so units place 5 into 5, 5. Again this 5, some number, 5 into 5, again 5. And this 5 into 5, again 5. So you multiply 5 any number of times, units place will always be 5. Basically 5 की कोई भी power ले लो, you take any power of 5, units place of that power will always be 5. So it doesn't matter if you take 125 की पावर 15 या फिर 1 2 3 4 5 और यहाँ पे कुछ भी नंबर में ऐड करो एंड उसकी पावर भी मैं कुछ भी लू. Units place, if I'm asking of this power, it will be 5. Because 5 की पावर कोई भी units place will always be 5. Absolutely straightforward, absolutely easy. Why is this happening? वो इसलिए हो रहा है क्योंकि यूनिट्स अपन जब मल्टीप्लिकेशन करते हैं, when we multiply, units place of the product or multiplication only depends on multiplication of units digits, not any other numbers. ठीक है, अब ये होगी 5 की कहानी. The for other numbers it is similar. देखो, what is the units digit in this number raised to this? Units place is 5. 5 to the power anything, units place would be 5. Absolutely no question. Next is 12 raised to 33. Now let us come to units place 2. Units place 2, let us come. Question is 12 raised to 33 na? Before this, let us look at 2 raised to 33. Before this, let us look at 2 raised to 33. Now if we take powers of 2, let us write initial few powers of 2 and try to find out the pattern. 2 की power 1 क्या होता है? 2. So units place is 2. 2 square units place is 4. 2 cube units place is 8. 2 की power 4. 8 into 2 is 16. Unit place is 16 का 6. 2 की power 5 is 32. Units place is 2. 2 की power 6 units place is 4. 64 का 4. 2 की power 7, 128 का 8. 2 की पावर 8, 256 का 6. Can you see 2486, 2486? Again 2486, 2486 and so on. So can you see that powers of 2 are repeating in the blocks of 4? 4. 4 के ब्लॉक्स में 2 की पावर के यूनिट्स प्लेसेस रिपीट हो रहे हैं. आई एम जस्ट लुकिंग एट यूनिट्स प्लेसेस. मैं बाकी नंबर को नहीं देख रहा. I am just talking about units place. So if you can see carefully, you will see that powers of 2 are repeating in the blocks of 4. So basically मुझे जब ये I want to find out units place of this 2 raised to 33. What do I really want to know? I want to know कि ये जो पावर है 33, ये ऐसे 4 के ब्लॉक्स पे कहां प्लेस होता है? ऐसे 4 के ब्लॉक्स में वो कहां प्लेस होता है? दैट इज व्हाट आई वांट टू फाइंड आउट. तो 33 कहां पे आएगा? 1 यहां पे आएगा, 2 यहां पे आएगा, 3 यहां पे, 4 है, 4 आएगा, 8 भी यहां पे आएगा, 12 यहां पे आएगा, 16 यहां पे आएगा, बिकॉज रिपीटिंग 4 के ब्लॉक्स में हो रहा है. तो 16 आएगा, वैसे 20 आएगा, 24 आएगा, 28 आएगा, 32 यहां पे आएगा. तो 33 कहां पे आएगा? 33 will come here. So unit place of this number is 2, right? Let us take any other number. 2 raised to 33 है ना? 33 तो फिर भी ऐसे देखने लायक था. What about 2 raised to 59? What about this number? What is the units place of this number? That if I want to find out this, then what do I have to find out? ये 59 जो है power, where does this 59 lie in this blocks of 4? Why 4? क्योंकि चीजें 4 के ब्लॉक में रिपीट हो रही है. तो टू फाइंड आउट वेयर डज 59 lie, हमें क्या देखना है? हमें बस देखना है कि when we divide this 59 by 4, what is the remainder? If we divide this 59 by 4, what is the remainder? जितनी भी रिमाइंडर है वो वहां पे जाएगा, क्योंकि 4 यहां पे कंप्लीट होगा. 0 रिमाइंडर है तो ये, 1 है तो ये, 2 है तो ये, 3 है तो ये, 0 पे ये, क्योंकि यहां पे खत्म हो रहा है 4 का ब्लॉक. फिर 1 2 3 0, 1 2 3 0. That is how it is working. So all we have to do is divide this 59 by 4 and find out the remainder. Now if you know 56 is 14 4s are 56. So 56 is divisible by 4. So remainder is 3. Because 56 plus 3 is 9. Na? So remainder is 3. So units place would be 8. Let us take some more example. 2 to the power 1 2 3 4. Now we want to divide this by 4. Again 4 का divisibility test we have not yet seen, but it is just dependent on last 2 digits. ये बाकी का मैटर नहीं करता. तो ये 34 को अगर आप डिवाइड करोगे 2 से, रिमाइंडर would be 2 because 32 is 8 4s are 32. So remainder is 2. So unit digit would be 4. कुछ भी ले सकते हो आप. 2 raised to 957,963. If you divide this by 3, you just have to divide 63 by 4. 63 को 4 से डिवाइड करोगे, रिमाइंडर इज 3. 60 is 15 4 the 60. 60 plus 3. So 3 remainder. So units place would be 8. 2 raised to 8 873921332. Last two digits 32. If you divide this number by 4, remainder would be 0. Last digit would be 6. It is as simple as that. You just have to divide power by 4, find out the remainder, and according to the repeated pattern, see where that remainder fits. Coming back to that 12 raised to 33. अब हमने क्या देखा? That units place of a power depends only on the units place of the base. अब यहाँ पे मैं 12 लिखूं या 312 लिखूं या 8312 लिखूं या फिर कुछ और लिखूं, it does not matter to the units place of this power. Units place will only be dependent on this 2. तो units place क्या होगी इस चीज की? That units place would be same as 2 raised to 33 का units place. And वो क्या है? You divide this 33 by 4. Remainder is 1. So units place would be 2. इतना ही करना है. And it is very easy. Same is the story for 3 की powers. ये 2 का हो गया ना. अब 3 की powers देखते हैं. 3 की power 1 is 3. 3 square units place 9. 3 cube 27 का 7. 3 raised to 4 81 का 1. अब देखो आगे 3 raised to 5 is 243 का 3. 3 raised to 6 971. So 3971 3971. That is how units place of the powers of 3 will repeat. तो 3 की भी power के units places of powers of 3 will also repeat in the blocks of 4. And why is this happening? This is happening because powers is nothing but repeated multiplication, and only the units places are determining the power. तो वैसे ही आप 3 की भी निकाल सकते हो. 3 raised to 125. What will be the units place? You just have to divide this 125 by 4. Why? Because blocks of 4 है. If you divide this by 4, you will get remainder as 1 because 24. Last two digit देखना है बस. 24 plus 1. So 1 है तो last units place is 3. 3 raised to 1 2 3 4. What is the remainder? Here 1 2 3 4 divided by 4. मतलब 3 4 divided by 4. Remainder is 2. Last place is units place is 9. उतना ही देखना है. That is all. And similarly, like 2, I can add any number of 1 2 3 4 5 6 and 3, and to the power 1 2 3 4 5. If I have to do this, what is the units place of this? Units place will only depend on this 3, not any other number. And 3 के लिए you have to divide this power by 4 and find out the remainder. 44 को 4 से divide करके remainder क्या होता है? 1. So units place is 3. That is all. I hope it is clear. Twelve raised to 33 हमने कर लिया. This 1 2 2 3 raised to 45. Again, only 3 will matter as far as units place is concerned. So and 45 you divide by 4, remainder 1. So units place is 3. That is all. Let us solve this. 3 raised to 5. 3 है raised to 5. 3 raised to 45. 45 remainder when we divide by 4 is 1 because 44 is divisible by 4. Remainder 1. So units place is 3. Here 5 raised to anything, units place is 5. And here 2 raised to 22. 2 raised to 22. 22 if you divide by 4, remainder is 2. So units place is 4. Right? So units place of this product is units place of is product of these units places. 5 into 20 into 3, which is 60. Units place is 0. That is all. But even if we are given multiple powers in multiplication format, you can just find out the units places individually and multiply those units places to find out the units place of product. Fine. Next, decimals. Decimals के साथ कैसे ऑपरेट करना है? It is same as multiplication, and multiplication and reverse of multiplication. So if you take 0.2 ka cube, if you take 0.2 cube, it is 0.2 into 0.2 into 0.2. Sorry, 0.2. It is, if you forget about decimal points, it is 8, and we have to give 1, 2, 3 decimal points. So you'll get 0.008 as the cube of 0.2. Then 1.2 square is 1.2 into 1.2, which is 1. 12 ka square is 144, and 1, 2, so decimal point here. And inversely, cube root of 1.69, it is plus minus 1.3, because 1.3 ka square is 1.69, and because we are taking square root, we can have positive or negative both values. Fine. Again, another example, 0.04 ka minus 1/2. So by definition, you know it is 0.04 ka 1/2, 1 upon 1/2. It is what is this? 1 upon 0.2, which is 10/2, which is 5. Right? Again, here plus minus, if you take, you will get plus minus here as well. If you take here plus minus, then everywhere it will be plus minus added. I hope this was clear. And square roots is just ulta of reverse operation of squares, and cube roots reverse operation of cubes. So if 0.2 cube is 0.008, then cube root of 0.008 is 0.2, right? But अगर ऐसा कुछ है कि 0.08 का cube root अगर मुझे निकालना है, then that is not 0.2. Please note that 0.008 का cube root is 0.2, but 0.08 का cube root is not 0.2. It will be a different number, which is very, very different from this 0.2. I hope you can understand this and take a note of this. It's just extension of our multiplication and squares and cubes and cube roots, right? Operating with decimals. If you have any doubts, do let me know in this section as well. This was asked in CSE 2023. Now let us see how easy question this is. Units digit in expansion of this. Now what we have seen, only this 2 will matter in the units digit. Other these numbers 5, 7, 2, 4, they have absolutely no role in determining the units place of this power. So this 2 raised to something. What is this? 9 into 7 into 5 into 3 into 1. All we have to do is find out what this product is. What is this product? If you do 105 into 9, so it is 945. So this is 2 raised to 945, something at the end 2 raised to 945, and 945 if you divide by 4, 45 at the end. So remainder is 1 when we divide by 4. So 2 raised to 1 at the units place we have 2. Answer is A. As simple as that. I hope you can appreciate that this has been repeatedly asked question, and it is very, very easy. This year they have asked about power kit 2 ki power. Then next year they can ask about 3 ki power, 5 ki power, 6 ki power, 9 ki power. Everything will follow a pattern. If you look at 9 ki power, it will be 9 ki power 1, 9, 2, 3, 4, 5. So it is just the repetition of 2. Right? 6 ki power, again, all the unit places of 6 ki power is 6. 9 ki power, odd powers are 9, even powers are 1. Just see the pattern and you will be able to solve these questions. Just remember that when we want to determine the units place of power, only the units place of the base will determine that. And after that, just see the pattern and you will be able to answer. I hope that was clear. Next is very, very important chapter of prime numbers and prime factorization. Prime numbers are at the foundation of the number system, because every number can be written as product of prime numbers or their powers, which is called prime factorization of that number, and it can be written uniquely up to order. So ulta pulta kar sakte ho numbers ko, but overall that is why prime numbers are called building blocks of the number system. Prime number is a number that is divisible by only 1 and itself. So for example, if you take 3 is only divisible by 1 and itself. There are no other factors of 3. 2 only divisible by 1 and itself. 5 only divisible by 1 and itself. But if you take 4, so 4 has 3 factors, one itself, 1 and 2. 2 is a factor of 4. That is why 4 cannot be called as a prime number. They are called composite numbers. Numbers which are prime numbers, numbers which are not prime numbers are called composite numbers, and this terminology has been used by UPSC. 1 is a unique case. It is neither prime nor composite. So please don't call 1 a prime number or a composite number. 1 is neither prime nor composite. Then we have prime and composite numbers apart from that. And one more exercise you need to remember: prime number till 100. It is very easy. There are only 25 prime numbers till 100. First 4 are these 2, 3, 5 and 7, and then 2, 3, 5, 7. Next would be 11, 13, 17, 19 and so on. So these are first few prime numbers. You have to remember at least few of them, because the question was asked this year on simple observation of prime numbers. You need to remember prime numbers till 100. Then few questions. 6 is a prime number or not? No. 2 and 3 are factors of 6, so 6 cannot be a prime number. 15 a prime number or not? No. 3 and 5 are factors of 15. Then is 1 a prime number? No. 1 is a composite number? No. 1 is unique? Yes. A number greater than 1 with exactly 2 factors, that 1 and number itself is a prime number. And list the number from 1 to 100, prime numbers from 1 to 100. I can do that, but please do the exercise yourself. Take help of internet if you face any difficulty. But remember that you should remember all the prime numbers from 1 to 100. The reason is here, CSE 2023. Are there any even prime numbers? In general, even number has 2 as a factor. So any even number cannot be prime number because 2 is a factor. But an only exception is 2. 2 is the only even prime number. 2 is also the smallest prime number because 1 is not a prime number. So 2 is the smallest prime number. It is also only even prime number. So if you get a statement like all prime numbers are odd, then that is not correct. 2 is a even number, also a prime number. It is the only even prime number. No other prime numbers are even apart from 2. 2 को छोड़ के कोई भी और prime number even नहीं होता, because all other even numbers will have 2 as a factor. So you need to really highlight this in your mind, that 2 is a prime, 2 is the smallest prime, and 2 is even. So ये एक बात याद रखना. Fine. All other prime numbers have to be odd, because no other even number can be prime, because उनका 2 तो factor होगा ही होगा सारे even numbers का. That is why except for 2, all prime numbers are odd. Then this statement is absolutely correct. But all prime numbers are odd, that is not correct, because 2 is a prime number which is even. Now this question was asked in CSE 2023. Choose a group which is different from others. Now if you observe carefully, 17, 37, 47, 97, and all these numbers, they clearly are odd and they clearly are prime number, except this 91. Except for this 91, all others are prime numbers. This 91 is not a prime because 13 sevens are 91. So it is divisible by 7 and 13. That is why 91 is not a prime number, and option D is hence odd among these 4. That is what was asked. And see, if you know all the prime numbers from 1 to 100, this was just about observation. It would take you just 10 seconds to solve this question, because it is just about observation, observing that this 91 is not a prime, and everything else is a prime number. So this must be odd. Then this type of question has been asked for past 2-3 years continuously, and this question has been repeated as well. With respect to prime P and composite number C. I have told you what prime is, I have told you what composite is. And to solve these kinds of question, firstly, you have to see that statement is always can be. So possibility, it is talking about possibility. So possibility is always there. And to solve, to be really certain about this, what we need to ensure that we need to know first few prime numbers, put in the values, and you will be finding the answer. So this 2p plus c can be odd. 2p is always even number. Even plus odd is odd. So can we have odd composite number? Yes, 5. Not 5, but 9. Yes, 15. There are infinitely many odd composite numbers. P into C can be odd. When the product of two things is odd, then both of the numbers is odd. Then can we have prime odd number? Yes. Can we have odd composite number? Yes. Anything you can take 3 into 9, 27. Yes. And similarly, P plus C, P minus C can be odd. I think here prime you can take as 11, composite you can take as probably 9. So 11 plus 9, 20, 11 minus 9, 2. So 20 by 2, 10 is an even number. So just put the values of first few prime numbers and you'll see that all the three statements are correct. Now this is 23, this is 22. Look at the statement 3 here and statement 1 here. P into Q can be odd. Here P into C can be odd. Same statement, absolutely same statement repeated. Similarly, other things also you can do, just put in few values and you'll be able to do. And both the places answer is D here and D here. All the statements are correct. And question is also about possibilities, can be. So can be to correct hai hi. So all the statements are correct at both the places. Again, a simple question on prime numbers. It is data sufficiency question. Question is a unique natural number between 10 and 20. The question itself tells us that this number we are looking for is between 10 and 20 and it is a natural number. But question asks if it is unique. So can we answer this question? That is what something we have to comment. First statement, n is a prime number. What is prime number between 10 and 20? We have 11, 13, 17 and 19. So four possibilities. So statement 1 alone cannot give us unique answer. Yes. Then statement 2, n leaves remainder 1 when divided by 4. Statement 2 alone से हमें क्या मिलेगा? Remainder 1 when divided by 4 मतलब 12 plus 1 13 and 16 plus 1 17. Still we have two options. If we combine the information, do we have unique answer? No. So here answer would be together also are not sufficient to answer. What is n? That is the question. What is n? We cannot answer it uniquely. We have 13, 17 even if we combine information in the both the statements. So answer here is D. All we needed to know was prime numbers between 10 and 20. See, is P into Q an odd integer? First statement, P and Q both are prime numbers. Based on that, can we say that P into Q is odd or even? If we to comment on P into Q odd or even, we need to know about P and Q being odd or even. This can be odd only when both are odd. This can be even when one of them is even. So can we have two odd prime numbers? Yes. So product can be odd. Can we have one even and one odd prime number? Yes, because 2 is an even prime number. So this can be even or odd depending on what is P and Q. So statement 1 alone cannot give us definitive answer. ये तो बस प्राइम नंबर दिए है ना, प्राइम नंबर तो कुछ भी हो सकते हैं, दोनों में से एक 2 हो सकता है यार, फिर दोनों भी ऑड हो सकते हैं. अगर दोनों ऑड है तो ये प्रोडक्ट ऑड हो जाएगा, अगर एक इवन है मतलब 2 है कोई दोनों में से तो इवन हो जाएगा. सो आंसर हम यूनिकली नहीं कर सकते. हाउ अबाउट सेकंड स्टेटमेंट, P plus Q is an odd integer. When is addition of two numbers odd? When one of them is odd and one of them is even. तभी एडिशन ऑड हो जाएगा ना. ऑड प्लस ऑड भी इवन होता है, इवन प्लस इवन भी इवन होता है, even plus even is also even, odd plus odd is also even. So if this addition is odd, then one of them is odd and another is even. ये तो हमें पक्का से पता है from statement number 2. And अगर ये पता है, if you know this, can we comment on this? Is PQ an odd integer? No, it is not an odd integer. Even into odd would be even number. But this is a data sufficiency question. Data sufficiency में we don't have to find the answer to question. We just have to comment on whether it is possible to answer. Now based on this information that P और Q में से एक even है और एक odd है, based on this information, have we answered the question or not? Yes, we have definitively answered that this P into Q is not odd integer. Is PQ an odd integer? Answer is no, but that is a definitive answer. हम may भी नहीं बोल रहे, हो भी सकता है नहीं भी हो सकता है नहीं बोल रहे. We are not saying yes or possible. Both are possible. Yes be possible, no be possible. Like we said in statement number 1, depending on P और Q odd है even है क्या है उस पे depend करेगा ये. But यहाँ पे based on statement number 2, we definitely know that this product is not an odd integer. So answer we have found. Question is, can we answer this question? Yes, we have answered. Na answer is negative. That is fine. So Statement 2 alone is sufficient to answer the question. Yes, we have answered the question. Answered itself can be negative, that is not an issue, but we have answered the question based on statement 2 alone. अब इसमें हमें क्या knowledge चाहिए था? कुछ नहीं चाहिए था, बस we needed to know that when we have addition of two integers as odd, then one of them is even, one of them is odd. And then once we know this product is always even, it cannot be odd, right? So answer here is B. I hope this was clear. Let us start with new section, which is prime factorization. What do we mean by prime factorization? As I said, every number can be broken down into multiplication of prime numbers or their powers. कोई भी number ले लो. Let us, for example, take कोई भी number. Let us take 60. Let us take 60. I can write it as anything like 6 into 10. I can write this 6 as 2 into 3. I can write this 10 as 2 into 5. And I can do this until I get all the prime numbers. अब यहाँ पे सारे prime number है कि नहीं देखो. And then I'll combine this 2 and 2, write this as 2 square into 3 into 5. This is called prime factorization of 60. कोई भी और number ले लो. Let us take थोड़ा बड़ा number ले लेते हैं. 1024. चलो. I can write this as you can see that this is divisible by 4. So 4 से divide करते हैं. 4 into 256, which is equal to 4 into 16 square. 16 into 16 equal to 2 into 2 into 16 is 2 power 4, 2 power 4. So this is 2 की power 1, 2, 4, 4, 8. This is 2 की power 10. This is the prime factorization of 1024. Let us take a more example. 360 is equal to, I can write it as 36 into 10. Then 36 is 4 into 9 into 2 into 5. And this is 2 square into 3 square into 2 into 5 equal to, I'll combine these two. This is the prime factorization of 360. So basically we are writing down this bigger number as a product of prime numbers or their powers. And this is true, this can be done for all the numbers, all the natural numbers, that is, we can write all the natural numbers as product of prime numbers or their powers. अगर number prime ही है, like 17 है, तो उसको कुछ और लिखने की जरूरत नहीं. 17 is equal to 17. That itself is a prime factorization of 17. But if the number is composite, we can write it as prime numbers का multiplication, prime numbers or their powers का multiplication, right? This way we will get some prime numbers as a factor of given number. Process क्या है लिखने का? You can have this kind of process, that you divide this by smallest prime number, then smallest, then smallest, then smallest, and do this. और जो हमने अभी किया था, बड़े नंबर को छोटे छोटे करते जाओ और प्रोडक्ट लिखते जाओ. 36 4 into 9, 4 2 into 2, 9 3 into 3. So 2 square into 3 square, that would be prime factorization of 36. Now what next I want to highlight, or I want you to understand, is how we can redefine our divisibility in terms of this prime factorization. We now understand that every number is made up of bunch of prime numbers or their powers, repeated prime numbers, or they appearing singly. So any prime number, any number, let us write, let me write any number. N is a number which is like this: 2 raised to 17, 3 raised to 15, and some 5 square, 7 cube, 11 raised to 9, and 17. Something. This is some number, and this is multiplication. This is the prime factorization of this number n. It is a huge number. So if I want to comment on another number m, which is, let us say, 2 raised to 10 into 3 cube into 5 raised to 7 I want to know if this m is factor of this n or not. What I can say is that this number m is factor of this number n only when this all the prime factorizations, all the prime factors to the respective power are factors of that number n. मतलब अगर this in this number m यहाँ पे 2/10 है, तो वो 2/10 ऊपर भी होना चाहिए, then only we can say that it is a factor. अगर वो नहीं है तो that is not a factor. For example, here we have 2/10, here we have 2/17. So yes, 2/10 तो यहाँ पे है, यहाँ पे 17 है ना, यहाँ पे तो 10 ही है. if we see how many twos appear in multiplication form in this number, यहाँ पे 17 बार आता है 2 और यहाँ पे बस 10 बार आता है, तो यहाँ पे ज्यादा है. So 2/10 is sitting inside that. So 2/2 is 10 is not an issue. 3/3 यहाँ पे 15 है, यहाँ पे 3 है. So yes, that is also not an issue. But यहाँ पे देखो 5/7 and यहाँ पे 5/2. तो even though this number is bigger, here 5 appears only twice, here 5 appears 7 times. So that is why this m cannot be a factor of this n. अगर मैं यहाँ पे 7 की जगह 1 ही कर दूं तो yes, यहाँ पे 2 है, यहाँ पे 1 है, यहाँ पे 3 है, यहाँ पे भी 3 है, 5. So now this number m completely sits inside this number n. ये जो नंबर n है इसका अगर प्राइम फैक्टराइजेशन लिखे एंड ये m का प्राइम फैक्टराइजेशन लिखे तो you can see that ये m के सारे प्राइम फैक्टर्स टू द रिस्पेक्टिव पावर्स they are sitting inside this number n. That is why we can say that this m is definitely a factor of n. In fact, we can say that any number is a factor of this number m only if उसके जो प्राइम फैक्टराइजेशन है दैट नंबर कोई भी अगर l है, this l will be factor of this number n only if it has only this prime numbers as its factors and उसकी पावर इससे कम हो, then only we can say. This is how we want to understand the divisibility in a different way and it will simplify many of the things for us as we'll see. So in other words, I can say that any factor of this number n will look something like this: 2 की power something, 3 की power something, 5 की power something, 7 की power something, 11 की power something and 17 की power something. इसका हर फैक्टर ऐसा ही दिखेगा. कोई भी ऐसा नंबर जिसमें इसके अलावा कोई प्राइम नंबर है वो इसका फैक्टर हो ही नहीं सकता, बिकॉज इसके पास ही नहीं है तो वो छोटे वाले को क्या देगा. That number then cannot be a factor of this. अगर इसके पास ऐसा है कुछ 19 भी है, then this number cannot be factor of this n. वो कुछ और नंबर है, that cannot be factor of this number n. और n is not divisible by this number जो भी नया है, अगर यहाँ पे 19. बट अगर ऐसा है एंड यहाँ पे we have number less than equal to 17, यहाँ पे we have less than equal to 15, यहाँ पे we have less than equal to 2, यहाँ पे we have less than equal to 3, यहाँ पे we have less than equal to 9, यहाँ पे we have less than equal to 3, then we can say that this number will be a factor of the bigger number or this n is divisible by this number. ठीक है, I hope it was clear. So इससे हम ये भी पता लगा सकते हैं कि हाउ मेनी फैक्टर्स आर पॉसिबल. मतलब ये क्या, हम यहाँ पे 2 की पावर क्या क्या हो सकती है. वी कैन हैव 0, वी कैन हैव 1, 2, 3, 4 ऐसे करके 17 तक हो सकते हैं. So there are 17 possibilities for this particular blank. Here 15, no sorry 17 नहीं, 18, 0 से लेके 17, यहाँ पे 16, 0 से लेके 15, यहाँ पे 3, यहाँ पे 4, यहाँ पे 10 and यहाँ पे 4. So number of possible factors of this number n is this. ये हम ज्यादा क्लियरली परम्यूटेशन कॉम्बिनेशन में देखेंगे, बट जस्ट एज अ साइड नोट आई एम मेंशनिंग दैट नंबर ऑफ पॉसिबल फैक्टर्स ऑफ दिस नंबर इज दिस. अगर यहाँ पे अभी समझ नहीं आया फैक्टर वाला चीज लास्ट वाला तो कोई बात नहीं, विल रिविजिट इट. Whatever I said, I have written this here. Divisibility can now be better understood with this understanding. A number n is divisible by a prime number p if and only if p appears in the prime factorization of n. This is because we are writing prime factorization. We are basically enlisting all the prime numbers and writing them in expanded format. If the prime number does not appear here, it is certainly not a factor of a given number. Further, n is divisible by another number m if and only if the prime factors of m are also prime factors of n with respective powers. वही जो चीज मैं बोल रहा था वो यहाँ पे लिखी है. You can go through it. Let us see a few questions that have been asked. This was asked in CSE 2022. Question is, this number is divided by this, then what is the remainder? Now, it may look intimidating, but all we have to see is prime factorization of this 1261. 1261 is difficult number to factorize, so you have to start from 2. You have to look for prime factors of this, 1261. 2 है क्या factor? नहीं. 3 no. 4 5 no. 7 no. 11 no. But if you divide this by 13, you will get this as 13 into 97. ये ट्रायल करना पड़ेगा, ट्रायल एंड एरर करना पड़ेगा. You have to divide it by 2 3 5 7 11 and then you reach to 13 and you will see that this number is nothing but 13 into 97. And A करने के लिए I think you should remember 13 का टेबल, otherwise divide करना difficult हो जाएगा. And 1261 once you understand that by as 13 into 97, इसको इससे divide करना है, 97 cancel हो जाएगा, 13 7 is 91. So it is complete divisibility. Remainder is 0. This 1261 is a factor of this multiplication. Remainder 0 हो जाता है. In any case, in 90% of the cases, जब भी UPSC पूछती है remainder के बारे में, answer is 0. Again, what is the remainder when this number is divided by 100? 100 क्या है? 100 is nothing but 4 into 25 is equal to 2 square into 5 square. Now we have to check कि क्या यहाँ पे 2 square into 5 square आते हैं. 2 square आता है क्या देखना है. 2 square is 4. यहाँ पे आता है because this is 16 6 96. 16 is 2 4th, तो 2 square तो आता ही है, ये 4 से divisible है. And 5 square आता है क्या? 5 यहाँ पे एक बार आता है, यहाँ पे एक बार आता है. 5 is also 2 times. So again complete divisibility. Remainder is 0. Again, these are both, I think this is CSE 2023. Easy question. Next is, let us see this question. Question is, what is the maximum value of this m? ये n से इनको कोई लेना देना नहीं है. Question is, what is this maximum value of m? What are they asking? कि how many times 3 appears in this product? How many maximum number of times 3 appears in this product? So you can see 15, 3 will appear once. 12, 3 will appear once. 9, 3 will appear twice. 9 is 3 square, you have to remember that. 6, it will appear once. 3, it will appear once. This is all the times 3 will appear in this product. How many times? 6. Answer is B. As simple as that. This is again not an old question, CSE 2022 question. Next question. This was asked in 2022. Not very difficult question. We are having a 2-digit number and numbers consisting of same digits but in reverse order. Now this is again different from our place value question. There also we have seen this kind of question that we have a 2-digit number and we are reversing it. वो मैंने बोला था आपको कि that is identification or identity of place value से करना है ये वाला. But this is different question. यहाँ पे place value से नहीं करना है. यहाँ पे हमें क्या करना है? We have a number and it's ulta and the product is 2340. If you look at this 2340, this 0 meaning 10 is a factor. अब दो चीजों को मल्टीप्लाई करके, जैसे कैसे भी है ना, दो चीजों को मल्टीप्लाई करके 0 कब आता है एंड में? When those two are 2 into 5 और 4 into 5 और 6 into 5 और 8 into 5, यही पॉसिबिलिटीज है. अदरवाइज 0 आएगा नहीं एंड में कभी, आप अगर सोचो तो. या तो 0 कि मतलब 0 1 into 0 वगैरह ऐसा हो, बट अगर 1 into 0 हो तो उसका उल्टा 0 1 हो जाएगा ना. दैट इज नॉट अ 2-digit नंबर. Since we are looking for a 2-digit number, it can only be 2 into 5, 4 into 5, 6 into 5 or 8 into 5. So numbers can be 25 52 or 45 54 or 65 56 or 85 58. अब क्या है ये 2430 है, ये 5 into 2, ये 1000 के करीब आंसर है. ये 2000 समथिंग आंसर है, ये 3000 प्लस आंसर है, 6 इंटू 5 3000 होता है, 8 इंटू 5 4000 प्लस आंसर है, तो आंसर यही होगा. डिफरेंस बिटवीन दिस इज 9. This is one way of doing this. Another way of doing this is you factorize this 2430. 2430 is equal to 243 is 7 का क्यूब if you know. नहीं, 243 is 3 raised to 5. 3 raised to 5. So this is 2 into 3 raised to 5 into 5. इसको लिखो 2 into 3 into, राइट, ये है. अब इसको हमें दो चीजों में बांटना है, पी और क्यू में, सच दैट दोस पी एंड क्यू आर रिवर्सेस ऑफ इटसेल्फ एंड दोज आर 2 डिजिट नंबर. तो हम क्या कर सकते हैं, ये ग्रुप, तो 2 इंटू 3 6 हो जाएगा, तो 2 डिजिट नहीं है नंबर वो, तो ये नहीं होगा. अब ये कर लो, देखते हैं. 3 इंटू 3 6, 6 इंटू 2 3 इंटू 3 9, 9 इंटू 2 18. और पर ये इट वुड बी 3 डिजिट नंबर हियर, 27 इंटू 5, तो ये भी नहीं होगा. अब ये देख लो, 5 into this is 9 6 are 54, this is 54, this is 45. आगे उल्टा P and Q you got, that is your answer. I hope that was clear. If you need further explanation of these PYQs, please refer to our PYQ series on LevelUp IAS YouTube channel. Let us go to divisibility tests. Here I'm not going to spend a lot of time here because this is pretty static. Some things you must already be aware of, and this is a revision course, that is why I cannot spend a lot of time on the divisibility tests. Test of 2. When is the number divisible by 2? When it has 0, 2, 4, 6 at the units place. As simple as that. It is very simple, or the simplest test. तो कोई भी even number है, that will be divisible by 2, right? By definition. Test of 3. It is where what you do for test of 3 is you add all the digits, and if sum of the digits is divisible by 3, then number is divisible by 3. And this test of 3 is most asked or most used in our examinations, so please ensure that you really understand this test. For example, here if I have the number, what I do, I add all the digits. 4 plus 3 7, plus 4 11, plus 3 14, plus 2 16, plus 2 18. So sum of the digits is 18, which is divisible by 3. Yes, 3 6 is 18. So this number is also divisible by 3. As simple as that. You just add all the digits and see if the sum of the digits is divisible by 3. Now this was used in this question. This is a PYQ as well. Question is, how many prime numbers can you form from these digits? You might think that this is a permutation combination question, that how many prime numbers can be formed from these digits using all of them without repetition. तो सारे numbers use करने हैं, एक ही बार करने हैं और prime number बनाने हैं. Now the thing about prime number is it is very 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 difficult to check if the number is prime or not in general. तो ये 5 digit prime number check करना आपके लिए एग्जामिनेशन छोड़ो, क्लास में बैठ के भी करने की बात नहीं है. So no examiner will ask you this question if it was actually possible to form any prime numbers, because वो number prime बनाना या फिर prime है कि नहीं चेक करना is a big task. उसके लिए computers की जरूरत होती है, आपको नहीं पूछा जाएगा. So what is simple answer here is, because I want to use all the digits, सब digits को use करना है ना, तो अगर सबको एक एक बार use कर लिया तो what is sum of the digits? It is 15. 9 plus 3 12, 14 and 15. तो if the sum of the digits is 15, नंबर कोई भी हो, 1 2 3 4 5 हो या फिर 5 4 2 1 3 हो, कुछ भी हो, in any which order I form the number, sum of the digits is always 15, so that number is always divisible by 3. And because that number is divisible by 3, it cannot be a prime number. Prime number के लिए क्या चाहिए? Number has to be divisible only by 1 and itself. But अगर 3 factor है तो वो number prime नहीं हो सकता. तो अगर मुझे ये digit एक एक बार यूज करके नंबर बनाना है तो दैट नंबर कैन नेवर बी प्राइम. सो आंसर टू दैट क्वेश्चन that how many prime numbers can be formed using these digits? Answer is actually 0, no prime number, because वो number prime हो ही नहीं सकता. Divisibility test of 4, ये भी बहुत easy है, very easy test. What you do, you just check last 2 digits of any number, and if those are divisible by 4, number is divisible by 4. For example, कुछ भी हो 1 2 3 4 5 6, तो you just check this 5 6, ये divisible by 4 है, बिल्कुल है, तो this number is divisible by 4. और भी लेते हैं 1 3 7, कुछ भी और ले लो 72, 72, is it divisible by 4? Yes, so this entire number is divisible by 4. Anything. I can explain why this test is like that, but maybe we'll do it some other time. 34, is 34 divisible by 4? No, so this number is not divisible by 4. There is a mathematical explanation by about why this happens, but let us keep that aside for right now, because right now our purpose is to clear the exam. Fine, that is test of 4. I hope you remember. Now test of 2, 3 and 4. Test of 5, अगर यूनिट प्लेस 0 या फिर 5 है तो नंबर इज डिविजिबल बाय 5, अगर नहीं है तो 9. वेरी इजी. आई थिंक दिस वुड बी द सिंपलेस्ट. अगर एंड में 0 या 5 है तो नंबर डिविजिबल बाय 5 है. टेस्ट ऑफ 6, टेस्ट ऑफ 6 क्या है? 6 वी हैव टू रिमेंबर दैट इट इज 2 into 3. So if the number is divisible by 2 and it is divisible by 3, then it is divisible by 6 as well. But this thing can be extended as well. For example, if I have to check divisibility by, let us say 24. 24 I can write it as 4 into 6. I can also write it as 3 into 8. Right? So if the number is divisible by 4 and 6, can I say that it is divisible by 24? Answer is big no. But if it is divisible by 3 and 8, can I say that it is divisible by 24? Answer is yes. तो ये क्यों हो रहा है? What we have to check? To check divisibility by any number on the planet or on in your mind. In this case 24, we just write its prime factorization. तो क्या है prime factorization? 2 cube into 3. And because once we have written this prime factorization, all we have to check is the number divisible by 2 cube and is the number divisible by 3. अब prime factorization हो गया, दोनों नंबर सेपरेट हो गए, then we can check about divisibility directly. This 2 cube से चेक करो, 3 से चेक करो, and you are done. If you want to check if the number is divisible by, let us say 60. 60 क्या है? 60 is 2 square into 3 into 5. So if the number is divisible by 2 square, मतलब 4, 3 and 5, then number is also divisible by 60. Again, another number you can take 124. 124 is 4 into 31. So if the number is divisible by 4 and 31, number is also divisible by 124. Few more numbers. 180 is equal to, so it is 18 into 10 is equal to 2 square into 3 square into 5, right? So if 2 square, if the number is divisible by 4 and 9 and 5, then number is also divisible by 180. Divisibility का क्या मतलब है कि उस नंबर में 2 स्क्वायर भी है, 3 स्क्वायर भी है and 5 भी है, मतलब पूरा 180 है. That is what we mean by divisibility ना, वो होना चाहिए उसमें. That is all. That is how you can check divisibility of any number. Any number, however big, does not matter. You just factorize it and check कि क्या उसके हर प्राइम फैक्टर से जो चेक करना है वो डिविजिबल है या नहीं. प्राइम फैक्टर टू द रिस्पेक्टिव पावर. This is what I have written here. Test of 8. Test of 8 is just like test of 4. टेस्ट ऑफ 4 के लिए हम लोग लास्ट 2 डिजिट देखते थे, टेस्ट ऑफ 3 के लिए हम लास्ट 3 डिजिट देखेंगे. तो मतलब 1 2 3 4 5 1 2. So what do? We just check, is this 512 divisible by 8? If the answer is yes, then number is divisible by 8. That is all. Test of 9 is same as test of 3. Sum of the digits need to be divisible by 9. Test of 10 एंड में 0 होना चाहिए, दैट इज टेस्ट ऑफ 10. नाउ टेस्ट ऑफ 11, ये थोड़ा अलग है. 11 के लिए what we do is, if we have any number, we add alternate digits and take their sum. 1 plus 3 4, 9 plus 7 16 plus 9 25, and this is 2 plus 4 6 plus 6 12 plus 8 20. You take the difference. Difference is in this case 5. If this difference is divisible by 11, number is divisible by 11. यहाँ पे नहीं है, 5 is not divisible by 11, so this number is not divisible by 11. But if I add this 5 here, then what will be the sum? This will also be 25 then, and 25 minus 25 0. 0 is divisible by 11 or not? Yes, 0 is divisible by everything. So then this number would be divisible by 11. तो करना क्या है? We have to take sum of alternate digits, and जो दो sums आएंगे हमारे पास, you have to take difference between that. If that difference is divisible by 11, मतलब 0, 11, 22 ऐसा कुछ है, then that number would be divisible by 11. In the original booklet that has been uploaded on my channel, there are some practice questions. You may want to refer to that. Explanation है ये सब. ये देखो, ये number एक दिया है. The difference between the sums is 46 minus 35, which is 11, which is divisible by 11. Hence, this number is divisible by 11. Last test of 25. If the last two digits are 0, 0, 25, 50 or 75, then the number is divisible by 25. That is all. This was a question. Consider all the 3-digit number without repetition, using digits which are non-zero digits, which are multiples of 3, and s be their sum. So क्या करना है? We have to take 3 non-zero digits which are multiples of 3. तो मतलब 369, और उससे numbers बनाने हैं all the 3-digit numbers obtained using these 3. तो मतलब 369 हो गया, 396 हो गया, 639 हो गया, 693 हो गया, then 936 हो गया, and 963 हो गया. And let s be their sum. तो इनको सबको ऐड करके जो भी आएगा, that is s, and we have to check, is s divisible by 9, is s divisible by 74. दो चीजें चेक करनी है. You can directly manually check and answer करना है उसके हिसाब से. So just do it manually in this case. This is a question. The number this is divisible by 7, that is given. What is the value of this digit p? अब what we can do? You in this case you just divide manually, like हम हमेशा करते हैं. 3 7 यहीं पे करता हूं मैं. चलो, divide by 7. Start dividing. जब यहां तक आओगे ना, then either you can put these values of p, possible values of p, and check, or you reverse engineer the long division process. That is also one way. 7 4s are 28. 1. Then this 8 comes. 7 2s are 14. 4. 1. 7 5s are 35. 6. This 2. Then 7 8s are 56. 6 5. Then 7 9s are 63. So you will get 2 here, and that p comes here. Fine. Then what you do? You subtract. कुछ तो आएगा यहाँ पे. Then some remainder. Next digit is 3. Some digit here minus again some 7 का multiple. You subtract. You get some remainder and 6 here. Next digit. यहाँ पे कुछ आएगा remainder, and then you subtract some multiple of 7. ऊपर से 9 लोगे. Let me write it here. 6 लिया ऊपर से, subtract some multiple of 7, you get some digit here and ऊपर से 9 आएगा and then you subtract some multiple of 7 and you'll get remainder as 0 because divisibility has been given. तो यहाँ पे क्या होना चाहिए अगर रिमाइंडर 0 है एंड एंड में यहाँ पे 9 है तो यहाँ पे भी 9 होना पड़ेगा ना रिमाइंडर 0 होने के लिए. तो दिस हैज टू बी 49. तो दिस हैज टू बी 49. अगर ये 49 ये मतलब रिमाइंडर यहाँ पे 4 है राइट. तो सम मल्टीपल ऑफ 7 प्लस 4 6 आना चाहिए. तो मतलब ऐसा कौन सा 7 का मल्टीपल है जिसके एंड में 2 आता है. देखो 7 14 21 28 35 42 42 प्लस 4 46 आएगा. तो यहाँ पे 42 आना चाहिए. मतलब यहाँ पे 46 होगा. 46 का यहाँ पे 4 है अगेन 4 रिमाइंडर और एंड में यहाँ पे 3 आ रहा है. तो कहाँ पे 7 के मल्टीपल में 9 आ रहा है क्योंकि 9 प्लस 4 मिलके ही 3 आएगा. तो यहाँ पे 49 होना पड़ेगा और 4 रिमाइंडर के लिए यहाँ पे 53 होना पड़ेगा. अब 2 इंटू 2p माइनस सम 7 का मल्टीपल 5 रिमाइंडर देता है. तो 7 का मल्टीपल प्लस 5 इन 20s. तो 21 प्लस 5 26 हो सकता है या फिर 28 प्लस 5 और वो 33 जाएगा. यहाँ पे 20s में ही आंसर है. तो इट हैज टू बी 21 और फिर p हैज टू बी 6. दिस इज वन वे यू रिवर्स इंजीनियर दिस प्रोसेस. दैट इज वन वे. और अनदर वे इज जब यहां तक आ गए यहां तक ऐसे आ जाना यहाँ पे 2p आ जाएगा एंड यहाँ पे फिर वैल्यू ऑफ p यू कैन पुट एंड फाइंड द आंसर कि कहां पे कंप्लीटली डिविजिबल हो रहा है. दैट इज अनदर वे. ये देखो another one is this one is very simple question. Smallest number when multiplied by 7 use 1 only. अब इनको सीधा 7 से मल्टीप्लाई कर लो एक साथ ही कर लो. So, इनको 7 से मल्टीप्लाई करने के ये आना चाहिए. तो सबके एंड में 3 है. 7 3 जा 21 का 1 कैरी फॉरवर्ड 2 7 1 7 1 जा 7 प्लस 2 9 नहीं चलेगा. 7 2 जा 14 प्लस 2 16 6 नहीं चलेगा. 7 8 जा 56 प्लस 2 58 नहीं चलेगा. 7 7 जा 49 प्लस 2 51 का 1. बस एक ही पॉसिबल है. ठीक है वेरी सिंपल. Now xyz is a 3-digit number where x plus y plus z is not a multiple of 3. Then this is not divisible by. देखो xy xyz xy वगैरह हमने कब लिया था. In this kind of questions you should immediately think about place values and this is your homework. Just expand this using our place values and you will be able to find the answer. Expand this using place values, add everything and you will get the factors, 2 of the factors, and it is not divisible by 3 is not because it is given that x plus y plus z is not a multiple of 3. So you will get only once 3 as a factor. तो आंसर 9 यहाँ पे हो जाएगा कि बिकॉज नंबर टू बी डिविजिबल बाय 9 यू नीड 3 2 टाइम्स नॉट 1 टाइम. ऑल द अदर थिंग्स यू विल गेट एज अ फैक्टर. अगर आपको ट्राई करने में भी ना आए तो प्लीज रेफर टू PYQ वीडियो ऑन LevelUp IAS यूट्यूब चैनल. ये भी देखो बहुत सिंपल है. ऑल नंबर्स आर डिविजिबल बाय 2, ऑल नंबर्स आर डिविजिबल बाय 3. ये दिया है हमें, इट इज गिवन. Conclusion 1, all numbers are divisible by 6. Yes, 2 and 3 से divisible है तो 6 से भी होगा. We have seen because 6 is equal to 2 into 3. 2 से भी है, 3 से भी है तो 6 से भी होगा. Because 2 into 3 is prime factorization of 6. Conclusion 2, all numbers are divisible by 4. That is not necessary because 2 से divisible है, इसका मतलब 4 से होना चाहिए, ऐसा थोड़ी है. To be divisible by 4, we need number to be divisible by 2 twice. जैसे कि 6 is divisible by 2, but it is not divisible by 4. So statement 2, conclusion 2 cannot be drawn. So answer is only one conclusion. This you have to do manually. How many integers are there between 1 and 100 which have 4 as a digit but not divisible by 4? Just लिख लो 4 digit कहाँ पे आता है. एक तो 4 14 24 ऐसे आएगा, एक ऐसे आएगा 40 41 42 till 49. अब उसमें से जो भी नंबर 4 से डिविजिबल है उनको क्रॉस कर दो और गिनो मैन्युअली एंड दैट विल गिव यू आंसर. दिस क्वेश्चन जो मैंने ऊपर बताया आपको प्राइम वाला, दिस क्वेश्चन वेरी इजी. एन 8 digit नंबर लीव्स रिमाइंडर 0 when divided by 3. हाउ मेनी पॉसिबल वैल्यूज ऑफ b आर देयर? अब डिवाइडेड बाय 3 है ना, डिविजिबल बाय 3 है तो 3 की टेस्ट हमें याद है. सम ऑफ द डिजिट्स, व्हाट इज द सम ऑफ द डिजिट्स? this is 30 plus b. So you want this 30 plus b to be divisible by 3. तो क्या क्या हो सकता है b? b can be 0 because 30 itself is divisible by 3. 30 plus 0, 30. So 30 is divisible by 3. Then we can have 3, we can have 6, we can have 9. So there are 4 possible values of 3 which are divisible, which make this number divisible by 3. Very easy, right? R and S are different integers, both divisible by 5. Then which of the following is not necessarily true? One thing you can do, just put values and be done with it. Take different values, like addition has to be divisible by 5. Multiplication has to be divisible by 25 because 5 is factor of R, 5 is factor of S. So 25 has to be factor of R into S. But just take example like 5 and 10. So both are divisible by 5. 5 plus 10, 15 is not divisible by 10. So answer is B. B cannot be necessarily true. Next is BODMAS rule. Again, I'm sure that you have done this in your school days. BODMAS stands for bracket order division, multiplication, addition, and subtraction. It is the order in which you have to perform mathematical operations when all at one multiple operations are to be performed at once. For example, here. So here you can see that firstly you have to perform this bracket power, then this 2 by 2 divided by 2. This multiplication division you can do at once, and then addition has to be performed at last. So 3 has to be written separately. This is 5 into 2 by 2, 5 into 2 by 2. So this is 1 minus 6 plus this is 8 into 4 minus 2 is 2. So क्या आएगा? 3 plus 5, 8 minus 6 is 2, 2 plus 16. So that would be 18. Thus hence you can use BODMAS as BODMAS rule to find the answer. I'll not go into details of BODMAS, or I'll not give any practice problems. If you want any practice problems, you can refer to the booklets, or you can refer to full lectures, or you can find many questions on the internet as well. Next section is HCF or GCD and LCM. I'll take a 2-minute break and then I'll begin again. Okay, guys, let us continue with next section, HCF and LCM. In this section, basically, we want to understand what these two terms mean and how to find them. And as far as questions are concerned, questions on HCF have not been asked, but questions on LCM have been regularly asked, and that is why you need to be able to find LCM very quickly, and you need to be able to find LCM of multiple number at once. That is why we have learned prime factorization, which becomes very, very handy in this case. And to identify questions on LCM, it is very simple, and there is a distinct identifier. There are only 2 types of questions that have been asked, and we'll see some of them so that you understand when to use LCM and how to proceed with those questions. Firstly, we have seen what do we mean by factor. What do we mean by one number being factor of another number? We know this from our earlier education as well, and today we have understood that in terms of prime factorization. One number is factor of another number only when all the prime factors of this number to the respective power are also factors of the bigger number to the respective power. Then only we can say that this number is a factor of the bigger number. So multiples, and we are here talking about highest common factor and least common multiple. What do we mean by multiple? Multiple is number multiplied by some other number. So basically, if you talk about multiples of 3, then it would be 3, 6, 9, 12, etc. These are multiples of 3, and factors that we have already understood. Then we firstly talk about highest common factor, that is HCF, or it is also called GCD, greatest common divisor. Both of them mean the same thing. So if one term, if these terms are used interchangeably, do not get confused. HCF or GCD of two numbers is the highest possible number that is divisible, that divides both the numbers, or that is factor of both the numbers. So basically we have two numbers. This number will have number of factors, this number will have number of factors, and some of those factors could be common. the greatest or the highest among those common factors is what is highest common factor or the HCF. So for example, if we have these two numbers 18 and 27, what is the factors of 18? 1, 2, 3, 6, 9, 18. These are factors of 18. Factors of 27, 1, 3, 9 and 27. Now if you look for the common factors among them, 1 is always going to be common factor for all the numbers. Then we have 3 as a common factor and 9 as a common factor. Which is the greatest among these? It is obviously the 9. So 9 is the greatest common factor or the highest common factor or the greatest common divisor, GCD or HCF. This is the method which you can use. Just enlist all the factors and find out the highest. This can be used if we have smaller numbers, but if the numbers are larger, then we have to use another method of for finding the HCF. Now this is the method of prime factorization. Question: what is the HCF of 512 and 288? Now here I have found prime factorization of 512 and prime factorization of 288. 512 is equal to 2 raised to 9 and 288 is equal to 2 raised to 5 into 3 square. What is the common factor among these two? Well, because we want to talk about highest common factor, तो पहले common factor तो होना चाहिए. Common factor is 2. And what is the highest power of 2 that is common? 5. यहाँ पे 5 है, यहाँ पे 9 है, तो 5 common है. So this is going to be the highest common factor. Let us see few more examples, and I think you will be able to understand how to find out. Let me take random numbers. So let us take 360 and 700. 360. Let us find out the prime factorization. It would be 36 into 10 is equal to 36 is 2 square, 3 square, and 10 is 2 into 5. So it is 2 raised to 3 into 3 raised to 2 into 5. 700 is 7 into 100 is equal to 7 into 2 square into 5 square. Right? So what is the common factor here? Only 2. What is the power of 2 that is common? Maximum power? This is the HCF. 4. Sorry, 5 is also here. No? 5 is also common. Into 5 is common. Highest power of 5 that is common is 1. So this is 4 into 5. 20 is the HCF of these two numbers. Few more. Let us take few more examples. Let us take 60 and 500. 60 is 2 square into 3 into 5. 500 is 5 into 100, which is 4 square into 5 cube. No? 125 into 4 is. So what is the HCF? 2 is the common factor. Yes. Highest power of them 2. 3 is not there. 5 is common factor. Highest power of that is 5. Highest common power is 1. This is the HCF. 4 into 5 again 20. Let me write two numbers now, random numbers. And 2 raised to 3, 3 raised to 5, 7, 9, then 11 cube, 19 raised to 11, something like that, and 31 cube. If this is the prime factorization of this number m, another number n, m, 3 raised to some 10, 7 cube, 11 raised to 15, 17 cube, and 23 square, and 31 square. If this is n, this is m, these are both huge numbers, and we want to find out HCF, then what will be HCF? Common factor 3 is there, highest power 5 into 7 is common, yes, highest power 3. 11 is there, yes, common, highest power 3. Highest common power we are looking at. 17, yes, 17 not common, 19 not common, 23 not common, 31 is common, yes, 31 square. This is the HCF of these two numbers. And good thing about this is you can find out HCF of multiple numbers at the same time. For example, if I add one more number, L is equal to 2 cube, 3 square, 11 cube, and 17 square, 31. If I write down this as third number, and now I want to find HCF of this all the three numbers. So what we have to look for? Common factor in all the three. 2 is not common in all the three. 3 is common, yes. What is the maximum power of 3 that is common? यहाँ पे 2, 10, 5. So 2 is the maximum common factor. 11 is there, yes. 11 cube is there everywhere. 17 is here, but not there, so no common. And 31 is common. Highest, yes, 1 only. So this is going to be the HCF of these three numbers. All we have to do is write down prime factorization, look for the common factor, and then put the power which are the highest common power that is there at the over the respective prime numbers. That is the simple method to find out HCF. These are the properties of HCF that we can have. HCF of 2 or more numbers is always a factor of all the numbers. Yes, factor to hoga hi. It is a common factor. So factor to it's definitely by definition. If any number divides all the given numbers, it also divides the HCF of the given numbers. मतलब कोई और अगर common factor है तो वो highest common factor को भी divide करेगा, which is very obvious because highest common factor में हम क्या करते हैं, maximum जो highest common power थी तीनों में prime numbers की वो लेते थे, और अगर common लेंगे तो वो highest वाले से तो छोटी होगी, तो of course that will divide the highest common factor. तो every common factor will divide the highest common factor. Next, HCF is always less than or equal to all the given numbers. तो factor number से तो बड़ा नहीं हो सकता ना. Factor is like a smaller thing. Factor of a number is always smaller or equal to or smaller than the number. So factor of a number has to be lesser than or equal to the number. So it cannot be bigger. HCF of two prime numbers is always 1. Prime number क्या होता है? उसके दो ही फैक्टर होते हैं, 1 and itself. और कोई और प्राइम नंबर उसके वो प्राइम नंबर और 1, तो कॉमन फैक्टर क्या हो, बस 1 ही हुआ, बिकॉज नो देयर इज नो अदर कॉमन फैक्टर, तो HCF भी 1 ही हो जाएगा. HCF of a number and the number which is not a multiple of it is always 1. HCF of prime number and some multiple of prime number is prime number. मतलब क्या बोल रहा है, कोई प्राइम नंबर 5 और द नंबर विच इज नॉट अ मल्टीपल ऑफ, मतलब दो ही कोई और नंबर जो कि इसका मल्टीपल नहीं है, तो इनका HCF क्या हो जाएगा, 1 ही हो जाएगा, क्योंकि ये इसका मल्टीपल नहीं, तो इसका कॉमन इसका फैक्टर क्या है, कोई और ले लेते हैं, चलो 21, इज नॉट अ प्राइम ना, तो इसके कॉमन फैक्टर्स क्या है, 1 and 5. इसके कॉमन फैक्टर में क्या है, कोई और है बट 5 नहीं है, बिकॉज 5 इसके मल्टीपल में नहीं है ये, तो इनका HCF क्या हो जाएगा, 1 ही हो जाएगा, बिकॉज ओनली 1 कॉमन फैक्टर इज देयर विच इज 1. और अगर ये 20 की जगह 5 की जगह 20 होता तो HCF क्या हो जाता, 5 हो जाता. कॉमन फैक्टर इज 5, 5 तो फैक्टर 5 का है ही और इसका भी है, तो HCF इज 5. So examples, HCF of 2 and 9 is 1 because 9 is not a multiple of prime number 2. HCF of 17 and 17 and 51 is 17 because 51 is multiple of 17. Co-prime number, again you should know this terminology. Co-prime number is any two numbers जिनका HCF 1 है. These are called co-prime numbers. Co-prime number need not be prime numbers. दोनों composite हो सकते हैं और फिर भी co-prime हो सकते हैं. For example, let us take 8 and 27. 8 and 27. 8 is 2 cube. 27 is 3 cube. So there is no common factor between them. Only 1 is the common factor. So HCF 1 है. 8 and 27 would be co-prime numbers, but both of them are not prime numbers. Both of them are composite numbers. तो ये बिल्कुल हो सकता है कि numbers could be composite, but their HCF could be 1, so they can be called co-prime numbers. देखो 4 and 9, these are also co-prime numbers, no common factor. 245 and 3, again co-prime. 2 and 5, co-prime. Right? Note that if one of the two numbers is prime, then the numbers are co-prime if other number is not divisible by that prime number. मतलब ये है 2 and 5 है, तो अगर 5 2 से divisible नहीं है, तो naturally HCF would be 1 and they will be called co-prime numbers. Two even numbers can never be co-prime. Why? Because 2 will always be common factor of both of them. Even number का 2 तो factor होता ही है. That is why they will not be co-prime. Two consecutive numbers are always co-prime. Now consecutive मतलब क्या होता है? 7 and 8, 9 and 10, 11 and 12, या फिर 1000 and 1001. So those two consecutive number will always be co-prime. क्यों? Because common factor कोई होने का चांस ही नहीं है, एक से ही बढ़ रहा है ना, तो common factor एक ही होगा. There cannot be any other common factor. ठीक है? Next is least common multiple. अब मल्टीपल क्या होता है हमने देखा, फॉर एनी नंबर m, 2m, 3m, 4m, 5m, these are all the multiples of that number m. वैसे ही अनदर नंबर n ले लो, तो उसका n, 2n, 3n, 4n, 5n. सो इन दोनों मल्टीपल्स में कुछ अगर कॉमन मल्टीपल्स होंगे तो उनमें से सबसे छोटा is the least common multiple. It is the smallest common multiple in these two lists. It's called as LCM. Note that multiplication of two numbers will always yield a common multiple. मतलब कोई भी नंबर मुझे ले लो कि जैसे 15 और कुछ 20. If I want to talk about LCM of these two numbers, तो पहले तो इसके कुछ मल्टीपल्स लेंगे, इसके कुछ मल्टीपल्स लेंगे और उसमें से कुछ कॉमन होंगे. कॉमन कब होंगे ही होंगे? क्यों होंगे ही होंगे? कुछ तो कुछ, क्योंकि इफ यू कंसिडर दिस नंबर 15 इंटू 20, तो ये 15 का भी मल्टीपल है, बिल्कुल है. 20 का भी मल्टीपल है, बिल्कुल है. तो मल्टीप्लीकेशन ऑफ दीज टू नंबर्स इज ऑलवेज अ कॉमन मल्टीपल. बट वो एलसीएम है कि नहीं वो डिपेंड करता है. एलसीएम क्या होता है? लीस्ट ऑफ द कॉमन मल्टीपल्स. कॉमन मल्टीपल्स तो बहुत सारे होंगे, बट उनमें से सबसे छोटा जो है वो है हमारा एलसीएम और लीस्ट कॉमन मल्टीपल. और एलसीएम निकालने की सबसे छोटी मेथड क्या है? अगेन विल रेफर टू आवर प्राइम फैक्टराइजेशन. दिस इज 3 into 5, दिस इज 2 square into 5. अब क्या करेंगे? We'll firstly look at anything common. 5 is common, yes. So we'll write 2 square, because LCM का 20 तो LCM का फैक्टर होना ही चाहिए, because it is a multiple. 20 का मल्टीपल है ना वो LCM. लीस्ट कॉमन मल्टीपल मतलब दोनों का मल्टीपल है, तो 20 का भी मल्टीपल है वो, तो उसमें 2 स्क्वायर तो होना ही चाहिए. तो 2 स्क्वायर मैंने डाल दिया. देन 3 होना ही चाहिए, बिकॉज दैट इज ऑल्सो दिस नंबर LCM इज ऑल्सो मल्टीपल ऑफ 15. और 5 भी होना ही चाहिए, क्योंकि यहां पे भी है वहां पे भी है, तो 5 भी होना ही चाहिए. तो दिस इज द लीस्ट कॉमन मल्टीपल ऑफ दीज टू नंबर्स. जो भी है, क्या 60 है ये? 60. ठीक है, कोई भी और नंबर ले लेते हैं थोड़े से. 30 एंड 45. 30 इज 2 into 3 into 5. 45 is 3 square into 5. LCM क्या होगा? 2 आना चाहिए, यस. 3 आना चाहिए, यस. यहाँ पे ये बोल रहा है एक बार दे दो मुझे, ये बोल रहा है नहीं नहीं मैं आऊंगा तो 2 बार आना चाहिए. सो 2 बार आना ही चाहिए, क्योंकि ये बोल रहा है ना इसको फॉर 45 टू बी फैक्टर ऑफ LCM और दैट LCM टू बी मल्टीपल ऑफ 45, 2 बार तो 3 आना ही चाहिए. दिस इज 3 स्क्वायर और 5 एक बार आना चाहिए. तो दिस इज द LCM. तो क्या करना क्या है? फर्स्ट थिंग, ऑल प्राइम फैक्टर्स ऑफ बोथ द नंबर शुड बी देयर इन द LCM, क्योंकि दोनों भी लोग फैक्टर है उसके. एंड पावर, जो भी उस प्राइम फैक्टर की, जो भी कॉमन अगर प्राइम फैक्टर है तो उसकी हाईएस्ट पावर आनी चाहिए वहां. दैट इज द थिंग. तो if I take again, I'll take random number 2 cube 3 5 7 raised to 9 11 cube into 13 square, and m is equal to 3 raised to 7 and 11 raised to 5 17 square 19 cube. If we have these two numbers, then what will be the LCM, least common multiple? multiple मतलब ये दोनों भी उसके फैक्टर होने चाहिए. तो ये है तो 2 आना चाहिए और क्यूब के साथ आना चाहिए. ये दोनों का पास 3 है तो 3 आना ही चाहिए. एंड ये बोल रहा है मुझे 5 बार चाहिए, बट ये बोल रहा है 7 बार चाहिए, तो 7 बार देंगे. देन 7 चाहिए चाहिए, 11 इसको चाहिए उसको भी चाहिए, एंड 11 इट हैज टू बी 5 times. 13 it has to be there, 17 it has to be there, and 19 it has to be there with third one. This is the LCM of these two numbers. I hope you understand how we are calculating LCM. We are writing down all the prime powers, all the prime numbers जो इनमें से किसी का भी फैक्टर हो, प्लस पावर्स उसकी जो है वो इनमें से जिसको हाईएस्ट रिक्वायरमेंट है उसकी दे देंगे, बिकॉज बोथ ऑफ देम हैव टू बी फैक्टर्स ऑफ दिस LCM. And I realize that I'm going a bit faster, but I hope you at least try to understand the procedure which I'm following and apply that in examination hall. It will yield you benefits. If you still want explanation for it, you can again go to our recorded course and refer that. ये देखो यही लिखा है मैंने प्राइम फैक्टराइजेशन वाला चीज. 40 is 2 cube into 5, 54 2 into 3 cube. These are common factors. तो LCM क्या आएगा? 2 आएगा ही आएगा, बट वो थर्ड पावर के साथ आएगा because it requires 3. 3 आएगा ही आएगा थर्ड पावर के साथ, 5 आएगा एक बार. So this will be the LCM. And this relation also can be used to find out LCM. LCM into HCF is equal to product of two numbers. So if you know the HCF, then you can find out the LCM. If you know the LCM, you can find out the HCF of two numbers. But for more numbers, it is always important to know how to find out LCM or HCF using prime factors. Next is some properties of LCM. All the numbers are factors of LCM because LCM is what? It is the common multiple, na? Common multiple है तो all the numbers that are in question are factors of that LCM, obviously. And LCM is always greater than or equal to all the given numbers. अब multiple देख रहे हैं ना हम लोग. Multiple मतलब क्या होगा? मेरे से चालू होगा लेकिन मेरे से बड़ा भी हो सकता है. मतलब 5, 10, 15 अगर 5 के multiples देखे जाए तो 5 at least 5 तो होना ही पड़ेगा. If you talk about multiples, so जो LCM है, even if you talk about least common multiples, it will always be bigger than or equal to the numbers. LCM of two numbers is one of the numbers if and only if other number is a factor. तो मतलब क्या है? 4 and 16 का LCM क्या होगा? 16 होगा, क्योंकि 16 का मल्टीपल 16 से ही स्टार्ट होता है. 4 के मल्टीपल में भी 16 आता है, 16 के मल्टीपल में भी 16 आता है. दैट इज द कॉमन मल्टीपल. इट इज आल्सो द लीस्ट कॉमन मल्टीपल. LCM of 8 and 56 is 56 because 8 is a factor of 56 and so on. मतलब ऐसे अगर दो नंबर आपको दिखे कि एक नंबर बड़े, दो नंबर है, एक छोटा एक बड़ा है और बड़ा वाला जो है वो छोटे वाले का मल्टीपल है, देन वो जो बड़ा वाला नंबर है वही अपना LCM हो जाता है और छोटा वाला नंबर ही अपना HCF हो जाता है. ठीक है. LCM of two co-prime numbers is their product, क्योंकि कॉमन कुछ है नहीं. मतलब if you write the prime factorization, co-prime नंबर के दो को-प्राइम नंबर है और उनका अगर आप प्राइम फैक्टराइजेशन लिखोगे तो उनमें कुछ कॉमन नहीं है, तभी तो LCM HCF अपना 1 है, तभी तो वो को-प्राइम है. तो LCM जो होगा उसमें सीधा सीधा मल्टीप्लिकेशन होगा, कॉमन कुछ होगा ही नहीं. Now let us go to the most important part apart from finding out the LCM, which is the questions, how to identify if the question is of LCM and how to solve it. अब ये देखो, this is CSE 2023. There are 3 traffic signals. Each signal changes its color from green to red and then from red to green. अपना जो traffic signal होता है वही. First signal takes 25 seconds, second takes 39 and third takes 60 seconds to change the color from green to red. मतलब 25 में green to red होगा, फिर 25 और सेकंड में red to green होगा. 25-25 मतलब 50 सेकंड में वो साइकिल पूरा हो जाए. The duration for green and red colors are same. मतलब 25 सेकंड green है तो 25 सेकंड red होगा, ऐसे चलता रहेगा. ठीक है. At 2 p.m. they together turn green. At what time they change the color green next simultaneously? So always in LCM questions what will happen is there will be different frequency of different quantities. यहाँ पे जैसे कि 3 सिग्नल है लेकिन अलग अलग फ्रीक्वेंसी पे चल रहा है. एक 25 सेकंड पे चल रहा है, एक 39 पे चल रहा है, एक 60 पे. There are 3 different frequencies of these signals for 25 seconds, 39 seconds and 60 seconds. There are 3 different frequencies in which they are running. That will be one identifier. Secondly, they will start together and question will be अगली बार वो कब साथ? When will they turn green simultaneously again? That will always be the case. तो फ्रीक्वेंसी है, अलग अलग फ्रीक्वेंसी पे वो चलते रहेंगे रिपीटेटिवली, अलग अलग, और पहले साथ में वो साथ at the starting point they will all start together and when will they be together again? That will be the question. जैसे यहाँ पे है we have 25 second, 39 second and 60 second. So if you take and we are asked when they will be green again. तो पहले green to red होगा, then again red to green होगा. तो मतलब first signal takes 50 seconds for the cycle, second signal takes 78 and third signal takes 120 seconds for the cycle. This is all in seconds. what we want to find out? We want to find out LCM, least common multiple, because they are running in different cycles. अगली बार कब सेम होंगे? जब वो अपने कॉमन मल्टीपल पे होंगे सेकंड्स। तो LCM निकालने के लिए 50 इज 2 into 5 square, 78 is 2 into 3 into 13, 120 is 2 cube into 3 into 5. What will be the LCM? LCM would be 2 cube, then 3, then 5 square into 13. These many seconds. वो seconds को आप these many seconds are there, converted into minutes. So divide by 60. 60 को इससे divide करोगे तो क्या आएगा? 15. तो ये 60 हट जाएगा, तो क्या बचा? 5 into 2 10, 10 into 13, 13 into 10 is 130 minutes, 130 is 2 hour 10 minutes, 2 hour 10 minutes, 2 के बाद मतलब 4:10. That is the answer, right? I hope you understand this. All we had to do was find out the LCM. LCM क्योंकि seconds में आ गया, तो we have to convert it into minutes. So minutes में 130 minutes हो गया, that is 2 hour 10 minutes. तो 2 के बाद 2 hour 10 minutes मतलब 4:10. ठीक है? Next, this is the type 2 of the question. This is one type, this is second type of question. दो ही type के question पूछे गए हैं. What is the smallest number greater than 1000 which when divided by any one of these numbers leaves the remainder of 3? अब इसको आप दो टाइप से कर सकते हो. One is of course just take these values, subtract 3 और डिवाइड करके देख लो. ठीक है, मतलब डिवाइड कर लो और देखो कहां पे रिमाइंडर 3 आ रहा है, एंड दैट शुड बी इट. जहां पे आ रहा है यू आर डन. Other way, what do we have? We have this number, some number which when divided by this is leaving the remainder of 3. तो मतलब उसमें अगर मैं 3 घटा दूं तो this number would be multiple of all these numbers or not, because every time it is leaving remainder of 3. मतलब क्या है, वहां तक जा रहा है और +3 आगे जाके ये नंबर आ रहा है. तो अगर 3 पीछे आ जाओ तो that quantity x minus 3 should be multiple of all these things. That is common multiple of all these things. Common multiple हम कहां पे पढ़ते हैं? LCM में. So we have to find out LCM of these things. 6, 9, 12, 15, 18. What is the LCM of all these things? This is 2 into 3. This is 3 square. This is 2 square into 3. This is 3 into 5. And this is 2 into 3 square. So LCM is 2 square into 3 square into 5. Correct? क्या है ये? Correct है ना? Yes. So this is 540 again, I think. This is 180. 180 is the LCM. Now, question क्या है? Question is we want a smallest number greater than 1000. So again, we have seen the property that all the common multiples in the future are also multiples of this LCM. This is the LCM. All the common multiples are also multiples of LCM. तो हमें ढूंढना क्या है? We have to find a multiple of 180 which is just more than 1000. 4-digit number की बात करें which is just more than 1000. If you remember the table of 18, 18 5s are 900, 18 6s are 1080. So if you do 18 6s are, it is 1080. So this is the smallest number greater than 1000, but remainder 3 है तो उसमें 3 ऐड कर दोगे तो आंसर आ जाएगा. So I have told you 2 ways. One way is you just divide these numbers by these quantities, and जहां पे भी आपको आ जाए रिमाइंडर 3 हर केस में, you are done. Or you find out the LCM of all these numbers and find out the some multiple of LCM which is just more than 1000 and add 3. Any one of them is fine. कोई भी यूज कर लो, but this is again repeatable question. 2-3 बार पूछा गया है, इसलिए I have mentioned it here. अब again question देखो. Joseph visit the club 5th day, Harsh visits 24th day, Sumit visits 9th day. तो चीजें अलग अलग फ्रीक्वेंसी में बट साइकिल में हो रही है. 5th day, 10th day, 15th day. and this guy is on 24, 48 वगैरह वगैरह, 9th day, 18th day and so on. तो if all of them meet on the same on the Sunday, स्टार्टिंग डे सेम है, तो फिर से कब एक साथ मिलेंगे, क्या करना है, एलसीएम निकालना है और उस दिन कौन सा डे होगा वो पूछा, कौन सा डे होगा 7 से डिवाइड कर लो और देख लो कितना आगे जाना। 3 क्लब्स है, गार्डनिंग क्लब्स मीट सेकंड डे, इलेक्ट्रॉनिक मीट्स थर्ड डे, चेस मीट्स फोर्थ डे। अगेन सी अलग अलग फ्रीक्वेंसी में मिल रहे हैं पर वो बढ़ते जा रहे हैं, साथ में एक साथ मिलेंगे एंड स्टार्टिंग में, एंड फिर कब एक साथ मिलेंगे, दैट वुड बी द क्वेश्चन। नहीं यहाँ पे थोड़ा और है, हाउ मेनी टाइम्स दे मीट इन 180 डेज, तो मतलब 180 दिन में कितनी बार एक दिन मिलेंगे, मतलब कॉमन डे पे मिलेंगे। ऑल यू हैव टू डू इज फाइंड आउट एलसीएम। एलसीएम इफ आई एम नॉट रॉन्ग यहाँ पे 60 आता है, सो 60 दिन में वो फिर से एक बार मिलते हैं, तो 180 दिन में दे विल मीट 3 टाइम्स, दैट इज द आंसर। यहाँ पे भी देखो 18 मिनट्स एक बेल रिंग होती है, सेकंड बेल 24 मिनट्स, थर्ड बेल 32 मिनट्स। इफ ऑल द बेल रिंग्स एट द 8 o'clock इन द मॉर्निंग, तो फिर एक बार साथ में कब बेल रिंग हो जाएगी। तो ऑल वी हैव टू डू इज फाइंड आउट एलसीएम एंड उसके हिसाब से कितना वो मिनट्स को आवर्स में कन्वर्ट करके आंसर निकालना है। सेम 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 अप्रोच, नथिंग चेंजेस। आई होप दैट इज क्लियर, दैट इज अ एलसीएम। नेक्स्ट इज फ्रैक्शन। फ्रैक्शन में हमें क्या करना है, वी जस्ट नीड टू अंडरस्टैंड फ्रैक्शंस। फ्रैक्शंस आर आल्सो कॉल्ड रैशनल नंबर्स। इसको ऐसे लिखा जाता है न्यूमरेटर डिवाइडेड बाय डिनोमिनेटर, एंड बोथ दिस न्यूमरेटर एंड डिनोमिनेटर आर इंटीजर्स। फ्रैक्शन shows some part of the whole, that is the fraction. Denominator can never be 0 because we have seen that dividing by 0 is not defined operation, so division by 0 is not allowed. ये टर्मिनोलॉजीज इंपॉर्टेंट है यहाँ पे। प्रॉपर फ्रैक्शन क्या है, इम्प्रॉपर फ्रैक्शन क्या है एंड मिक्स्ड फ्रैक्शंस क्या है। आई एम जस्ट चेकिंग कि कितना बचा है इस चैप्टर में, otherwise we'll make a different video for this too. Okay, there is a lot to do in this fraction thing. Fine, I'll make another video for this. I hope it was helpful for you guys, and we'll meet in the next lecture, and thank you, and let me know in the comment section if you are finding this helpful. If you have any suggestions or if you have any doubts, do drop them in the comment section and I'll get to you. Thank you.